Wait, what? It's going to be. No. Unstable reactor. Oh no, what has happened? Our reactor has been unstable. What can we do about it? Wait. Maybe just do this. Oh no, what did I just do? That was a bad idea. Wait, I know what this means. So what was the cause of this big disaster? Oh my bad. It was the cause of a extremely notorious particle. Okay, let's get into topic. Welcome to Beyond Infinity by Senul, where we explore various things about the universe that are very intriguing, exciting and very mysterious, and anything that is sci-fi related and anything that I like. So what are we going to talk about in this video? Well, I'll tell you that later. Before, hold on to me for a bit. I would like to tell you something new. So I've officially changed my channel name from Senul on Space to Beyond Infinity by Senul. Goodbye Senul on Space. So this is because I will be doing videos about science and many other things that I like, such as history and many others. So previously on my channel I was actually doing some astronomy videos and stuff that are space related. So I am still going to continue these videos, but I will be doing science videos as well as many other subjects as I wish. So you can enjoy all of these videos in one place, Beyond Infinity by Senul. So Beyond Infinity by Senul with a warming hug. Okay, let's get into today's topic. So today's topic is gonna be about atoms. So sit back, relax and enjoy this video. Atoms are the building blocks of matter and are the tiny particles that make up every substance. From air, water, rocks, plants, animals, and even to our very own human bodies, atoms make up all of them. They are the basic structure of any matter. They are the smallest units of an element that retain that element's chemical properties. The ancient Greeks thought that they were the smallest particles that were possible and that existed. In fact, the word atom itself came from an ancient Greek word atomos, which means indivisible. And in modern Greek, the word atomos actually means individual. So this basically means an indivisible individual. So these particles are individual and they cannot be divided further into more particles. You cannot see atoms with your naked eye or with even a light focusing microscope. You have to use a specialized type of microscope which is known as the electron microscope, because these types of microscopes can interact with the atom. Atoms are composed of three main particles, namely protons, neutrons and electrons. At the center of the atom is a dense nucleus that is smaller than the entire atom. In fact, it is so small that if it were the size of a marble, the atom itself would be the size of a sports stadium. Wow, that's a great comparison. So, in the nucleus, it consists of protons and neutrons. Protons have a positive charge and neutrons have no charge or a neutral charge. So, what is the force that actually binds these protons and neutrons together into one nucleus? Well, it is known as a strong nuclear force and is one of the four main forces of the universe. So what this basically does is it binds every single proton and neutron that is there in the nucleus. Even though protons are positively charged, and that means that if two of them meet together, they repel each other, they should still be held together by the much stronger strong nuclear force. That is why it's called strong. So let's talk about the electrons now. Electrons are tiny particles that have a negative charge. These electrons whiz around the nucleus at terrific speeds. It's not accurate to think of an electron orbiting around the nucleus as a planet would do around a star. It's more accurate to think of them wrapping around the entire nucleus. So, have you guys heard about the periodic table? Well, it's like a table which lists every single element that is known to man. So, all of these have given different types of properties and values, and we are going to use these values and properties in this video. If you want to find out the number of protons an atom has, then you will have to take its atomic number. This is a special type of number which shows what is the value of that atom. So let's say if you want to find out the number of protons in a gold atom, then you would have to take the atomic number 79, because that is the atomic number of gold. So this means that gold has 79 protons. Neutrons, on the other hand, can differ a bit, but they have a standard amount. So in order to find this standard amount, we need to take the atomic number and subtract that from the atomic mass. Now the atomic mass basically means the mass of that atom. So let's take calcium for example. Its atomic mass is 40 and its atomic number is 20. So 40 minus 20 equals 20. So there are 20 neutrons in a calcium atom. However, the number of electrons depends, because they are arranged in specific energy levels, or they are also known as shells. So the number of electrons depends on various criteria. So in the first shell, we normally have 2 electrons. On the second shell, we normally have 8 electrons. And on the third shell, for light elements, we have 8. And that can be even more. So a single atom can have lots of shells. And the energy is always lower when the shell is closer to the nucleus. So that means the outermost shell is the most powerful. And the electrons in that shell are known as the valence electrons, because their key role is to perform chemical reactions by bonding between other atoms. Even though atoms of the same element have the same number of protons, they can have different numbers of neutrons. And there are some atoms that exist like these. So these types of atoms are known as isotopes. Isotopes have slightly different masses than other atoms. Let's take 2 different atoms, carbon-12 and carbon-14. Both of these are forms of carbon, but carbon-14 has 2 extra neutrons than carbon-12, as you can see from the numbers. So carbon-14 is in fact an isotope. By the way, carbon-14 is also used to find the dates and different ages of ancient objects. So normally, atoms have a neutral charge, which means the number of protons equals number of the electrons. However, when the atom gains or loses electrons, it becomes a charged particle, which is named as an ion. So there are 2 types of ions, cations and anions. Cations form when an atom loses electrons, thus causing the protons to prevail and have a positive charge. So that means cations are normally positively charged. Anions, on the other hand, formed when atoms gain new electrons, making the amount of negative charges prominent. So anions are negatively charged. Both of these ions are very important when it comes to form compounds. Our understanding of the atom has developed over time. So let me give you a brief explanation. So in ancient Greece, a philosopher named Democritus proposed the idea that matter is particulate in nature. That means it has a lot of particles to deal with. So these particles were eventually called atoms, as I said before. Next, there was another modern scientist whose name was John Dalton. He was the first to list down all the elements that he knew in his day. And he proposed that atoms are solid, indivisible spheres and that were completely opaque. However, the next scientist, J.J. Thomson, said otherwise. He found electrons in a cathode ray tube and he proposed the plum pudding model. So he said that atom was more like a plum pudding. You get it, right? Okay. The next scientist's name was Ernest Rutherford. So Ernest Rutherford did a very famous experiment known as the gold foil experiment. In this, he took some gold foil and he fired some alpha particles through it. Some of the alpha particles actually got through the gold foil, while a few of them bounced back. Now this proved two things. Atoms were not completely opaque, but they still had some sort of small dense nucleus inside. So Ernest Rutherford was the first scientist to find out that atoms had a small dense nucleus. The next scientist, Niels Bohr, found electrons moving in fixed energy levels. And finally, the quantum scientist, Erwin Schrödinger, he found that atoms had electrons that were moving in probability clouds. Now, this may be a little confusing to you, but actually, it's what I said before. Electrons do not orbit atoms the traditional method. Instead, they wrap around the entire atom more like a cloud. So these are known as probability clouds. Atoms rarely exist alone. They combine with other atoms to form molecules and compounds and seek stable electron arrangement. So let's take a water molecule for example. A water molecule is formed of one oxygen atom and two hydrogen atoms. Now, the oxygen atom has more number of electrons than the other two hydrogen atoms. So it actually shares some of its electrons with the other hydrogen atoms. So this can show that atoms seek stable electron arrangement. So atoms explain everything in chemistry and almost everything in physics and biology too. So how would objects have a mass without particles in physics? And also, how would crucial chemical processes in our body take place without particles in biology? So this can show that not only they are available in the real world, but also in various subjects as well. Atoms are not so different from us humans. They always seek to bond with other atoms and share their electrons with them, just as we seek to bond with good companions and friends and share our good ideas with them. So the next time that you think that you're all alone and you don't have any friends, just remember that even the smallest particles can have good atomic companions and share their electron ideas with them. Thank you for watching this awesome video. I believe that you must have learned something valuable from it. If you did, just leave a like, comment and share this video, and most of all, subscribe to my channel Beyond Infinity by Senul so that you can get to see more awesome and cool videos like this about science and many others. So stay tuned for another awesome video. Till then, goodbye.